So welcome everybody. So just want to quickly show us something so vital in statistical inference 1 and statistical inference 2. Okay, so first of all, if you are meeting me for the first time, my name is Learning Stat. I'm a graduate of the Department of Statistics, University of Ibadan. So real quick, so I want to just quickly show you something under statistical inference. So you know, when we talk about sampling technique is one of the first things that you'll be introduced to in statistical inference. That's very, very certain. So now sampling technique can be divided into two. We have the probability or the random. That's the random technique. Then two, we have the non-probability or non-random technique. Okay. So now under this probability or random technique, we have various types. Likewise, under the non-probability or non-random. Under this probability or random, we have the simple random sampling technique. So we call it the S.W.R. We also have the cluster. We have the stratified. We also have the systematic, and we have the multi-stage. So we have the S.W.R technique, we have the clusters technique, we have the stratified technique, we have the systematic technique or method, we have the multi-stage technique or method. Now, my emphasis for today in this video is to basically talk about the S.W.R method. I want to show you something that is very, very important for you to know. Okay? Now, talking about this simple random sampling, the main characteristics of this simple random sampling technique, the main characteristics is that every member of the population, that if you are using a simple random sampling technique, every member of the population, they all have equal chance of being selected. That is the main feature of this S.W.R technique. They all have equal chance of being selected. So we have what we call the sampling with replacement, and we have what we call the sampling without replacement. So S.W.R is for sampling with replacement. S.W.R is sampling without replacement. Okay. Now I'm getting close to my emphasis for today in this video. Now, if I have a population that contains the element, let me call it population P, that contains the elements 1, 2, 3, 4. If I have a population that contains this element, now in that population, let's say in my exam question or my test question, what I was asked is that, okay, take a random sample size of 2 with and without replacement and calculate the following. Take a random sample size of 2 and calculate the following with replacement and without replacement and calculate the following. So they can ask you to calculate various things. They can ask you to calculate the mean of the population. They can ask you to calculate the standard deviation of the population. They can ask you to calculate the mean of the sampling distribution of the population, and they can ask you to calculate the standard deviation of the sampling distribution of sample mean. Okay, now, but that's not my emphasis for today. My emphasis for today is how do we take samples with replacement and without replacement. This is my emphasis. Sampling with replacement and sampling without replacement. That's my emphasis. So now, if I have a population that contains these members, and I'm asked to take sample size of 2. First off, what is my population size? My capital letter N here is what? 4. Right? Because I have 1, 2, 3, 4. The number of the members in that population is what we call what? And my population size. My sample size will be 2. That is, if the question is asking me to take a sample size of 2, then my sample size will be what? 2. Now, one thing you have to know is that the total number of members that can be formed from sampling with replacement, sorry, total number of samples that can be formed, rather, sampling with replacement is n raised to power small n. And the total number of samples that can be formed for sampling without replacement is capital letter N combination small n. Okay? Sampling with replacement, the total number of members that can be formed is n raised to power small n. While sampling without replacement, n combination what? Small n. Capital letter N combination small n. That's what without replacement. For those of you doing inference 1, this is a potential exam question. Okay? So, now, how do I form samples with replacement? The first thing I will do is to check what the total number of samples that I can form. For this one, what is my population size? S.W.R. We already know that it's capital letter N to power small n. So my capital letter N here is what? 4. Raised to power, what's my small n? 2. And that will be what? 16. 16. Now, sampling with replacement, I can form 16. That's if I have a population of size 4 and I'm taking samples of size 2 with replacement. Since I already know that it's 16, how do I form those 16 samples? Sampling with replacement, what does it mean? It simply means anything I take from the population, I can return it back to take again. Okay? So, let's form the samples together. So I can start with 1. That is, I take 1 out of the sample, out of the population rather. I return it back and take 1 again. That's 1, 1. First time I took 1, second time I took 1. Another way I can do it is I can start with 1, I can take 1 out of the population, return it back and take 2. I can take 1, return it back and take 3. I can take 1, return it back and take 4. I can start with 2. I can take 2 out of the population, replace it and take what? And take 1. I can take 2, replace it and take 2. I can take 2, replace it and take 3. And I can have 2, 4. What do you notice? I'm using 1. I used 1 here to pick everything. I move to the next one. I used 2 to pick everything. Same thing. 3. I'll use 3 to pick everything. I have 3, 1, 3, 2, 3, 3, 4. The same thing applies to 4. 4, 1, 4, 2, 4, 3, 4, 4. What do you notice in sampling with replacement? I can have 1, 1. That is, I can take 1, return it and still take 1. I can have 2, 2. I can have 3, 3. I can have 4, 4. Another thing you should notice is that I can have 1, 2 and I can have 2, 1. 1, 2, 2, 1. 1, 3, 3, 1. 1, 4, 4, 1. 2, 3, 3, 2. 2, 4, 4, 2. That is with replacement. Now, let's count it whether it give us 16 or not. 1, 2, 3, 4 in 4 places. 1, 2, 3, 4. 4 times 4 is what? 16. So you can see it gave me 16. Now, let's do for without replacement. Okay? Let's do for without replacement. Let me rub off this part. So, for sampling without replacement, that's S.W.R. Anytime you see S.W.R, it means sampling without replacement. The total number of samples that I can form is what? Capital letter N combination small n. And that will be what? 4 combination 2. And 4 combination 2 will give us what? It should give us 6. If I am not wrong. Yes, 4 combination 2 will give us 6. Okay? Now, how do I form these 6 samples? How do I form these 6 samples? Let me write my population here. 1, 2, 3, 4. How do I form these 6 samples from this population? Now, sampling without replacement means whatever I take out of the population, I cannot return it. That is without replacement. That is, you cannot replace it. So once I take it out of the population, once I sample it, I cannot put it back inside the population. Now let's start with 1. Once I pick 1, what am I left with? I'm left with what? 2, 3, 4. And with our basic knowledge in Stat.1, 1, 2, that's probability 1, introduction to probability, I can pick any of these 3 in how many ways? 3 ways. That is, I can have 1, 2, I can have 1, 3, and I can have 1, 4. Are you following? Now, if you notice that for without replacement, I don't have anything like 1, 1. It's not possible. I am done with using 1. Let me move to 2. 2, comma. So if I pick 2, I cannot return 2. So let me rub off 2. 2. Now I'm going to use 2 to pick the rest. But mind you, I can't use 2 to pick 1 because I have 1, 2. I cannot have 2, 1. Okay? So I will rub off 2 because I'm using 2 currently. And I'll rub off 1 because I have used 1. So what am I left out with? 3 and what? 4. So I can pick any of these 2 in how many ways? 2 ways. That's 2, 3, 2, 4. Abi? Now what's the next one? 3. Once I rub off 3, because I'm using 3 now, I'll rub off 2 because I have used 2. I'll rub off 1. I'll rub off 1 because I've used 1. I rub off 2 because I've used 2. I'll rub off 3 because I'm using 3. What am I left out with in the population? Just 4. Just 1 digit. And in how many ways can I pick this digit? Just 1 in 1 way. So that I will have what? 3, 3, 4. Let's count whether it will give us 6 or not. 1, 2, 3, 4, 5, 6. So you can see that the total number of samples that can be formed without replacement here is what? 6. Here we have 16. So anytime you are given a question like that, you have a sample size, you have a population size of 3, you take samples of 2. First thing you should do is to calculate the total number of samples you can form. Because sometimes you can have a population of size, let's say 4, and you are asked to take a random sample size of 3. It will help you to know, okay, how many samples are left to be formed? And how many samples have I formed? How many remaining for me to go? Okay, so that is one thing I always advise you to do. So first thing, always calculate the total number of samples that you can form. So whenever you are done with this, then you are good to go. You can now start forming your samples. So thank you for watching. This will be just the introduction. So there are more to this. This is just the basics. There is more to this inference. So thank you for watching. Hit the subscribe button. Kindly like, share, and subscribe, and follow for more. God bless you, and I love you.